Here is question 3B, part 1. So this is our question, and we've got some information about ages of cyclists at the 2012 Games. And the question is looking at how many cyclists in 2016 could be expected to be 30 years or more. So we've got this information in the very top sentence here we've got 489 cyclists in the 2012. So we want to use that information somehow. We've also got this word expected. Now, as soon as you see this word expected, I want you to go straight to thinking about this formula, E equals N times P. You're not given this on a formula sheet. This is something you just need to learn. So as soon as you see anything with expected, this is the formula. And we're talking about expecting to be 30 years old or more. So what we need to do is we first of all need to work out the probability. Okay, so we've got our graph, our little pie graph, and we've got some information about the different age groups. And we're looking for which age groups are 30 years or more. So to start with, I've got the 30 to 34-year-old age group, which is 18%. So that's going to be included in my probability. I've also got the 35 to 39-year-old age group. So there's another 7% we're going to add on. And we've got the 40 and older, which is 1%. So those three all meet the criteria 30 years or more. So we add that all up and that gives us 26%. Now let's turn that into a decimal. So 26 divided by 100 gives you 0.26. So now we've got that probability. Now we can connect that information as well as this 489 that we got in the very top. We're going to connect that information together to work out the expected value. So our N, our sample size, is 489, and we're going to multiply that by the probability of 0.26, and that's going to give us 127.14. Now if you get to this point, then that would give you an achieved level skill. Okay, that would get you a U. But we need to do more than that. So let's think about what it is that we've found. The question was how many cyclists could be expected to be 30 years old or more. So we're talking about how many cyclists. We can't have 0.14 of a cyclist. So that means we need to round this 127.14 to a whole number. So it can either be 127 or 128. So either of those answers would be accepted. And so if you get to this point, then that now gets you a merit or an R. Okay, so now there's one more piece that we've got to think about. We have been asked how many cyclists do we expect in the 2016 Olympics. But the 489 cyclists that we've been told, that's how many cyclists there were in 2012. So what we're doing is we're using data from 2012 to estimate information for 2016. So this is an assumption that we are making, and we just want to write a little sentence talking about this assumption. So I might say the data we've got is from 2012, but the number of cyclists that we're estimating is 2016. So we're going to assume that the number of cyclists will be similar. We're expecting that there is going to be around about 489 cyclists in the 2016 Olympics. Okay, then in level 2 and level 3 we might start arguing about whether or not this is a good assumption or not. At year 11 we want to recognize that we are making an assumption. We're assuming that 489 is going to be the sample size for 2016, but it is an assumption. And if we talk about that assumption, then that gets you your excellence T. Okay, so here's our marking grid. Calculating the expected value of 127.14 gets you the U. Rounding the expected value to a whole number gets you an R. And rounding the under and discussing the assumption is going to get you a T.